All right, welcome back, guys. This video we discuss a few properties of logarithmic functions. List some of the useful ones. There's a lot more. However, we want to focus on the three main ones, um, and they're important. It shows up here and there, but regardless, we still have to go over these properties and understand how to work with them. In a way, we already know these properties before we study logarithms because logarithms, in definition, it's just exponent of something, all right, raised to something equals something. So properties that involve logarithm essentially relate to exponents or exponential, or properties of exponents that we study early on, in chapter 1 and chapter 2, I believe. So yeah, so a little bit of that, you see this as we go over these three properties here. This saying that if m and n are m, n, and a are positive real numbers, so any positive real numbers, with a not equal to 1, let's go back to the definition of exponential function where the base itself can't be equal to 1, because otherwise it won't make sense. When you take 1 raised to anything, it's going to be just 1. It's not anything important there for us to study for that kind of function if it's constant at 1. And r is any real number here. Then we have these three main properties as stated here. So if we take the log base a of a product of two positive real number, then it turns out that we can actually expand this, kind of sort of like distribute, but not really. I wouldn't want to use the word distribute, but this becomes log base a of m plus log base a of n. Okay, so we can actually expand that to the sum of log base a of m plus log base a of n. And vice versa too, of course. If we start with a sum like this, we can actually condense it or compress it into the form on the left here. Moving on, next property, if we have log base a of a quotient, m divided by n, then this becomes log base a of m minus log base a of n. Okay. If we're given this difference here, we can also go backwards as well. One of the common mistakes is when students go from right to left, or the expanded form to the compressed form, is that, let's say they have something like here. Suppose we have something like this here, log, let's say 3 of x, minus log base 3 of y, for example. So when they go to the condensed form or compressed form, they'll say, okay, this is just log base 3 of x over log base 3 of y, right? So notice that that's not correct, because the rule said that it's the quotient. It becomes the quotient of the argument, which is x and y here, not log base 3 of x divided by log base 3 of y. So this is the incorrect notation here. I wouldn't write like this, because if we were to apply to a value, it will give you the wrong answer. So the correct way is you want to do log base 3 parenthesis and then take the x divided by y all together as a single quantity inside the parenthesis. Okay. Last rule, if we have log base a of m, and it looks like m is being raised to the r powers, so in this case we can actually bring down the power r, constant r there, and then multiply by log base a of m. Okay. Let's practice using the sum and difference of rules for logarithms here. If we're given log base a of 5 times w, let's go ahead and just expand this out, and this can be written as log base a of 5 plus log base a of w. Okay, and if we have a quotient inside the argument, that just become log base a of 3m, right, the numerator, subtract log base a of n, right? But we can even expand the first term furthermore because we have a product inside the argument there. So that just becomes log base a of 3 plus log base a of m minus log base a of n, right? Okay, let's do example 2, and this is using the product, quotient, and power rule all together. So part A said log base 2 of the product of a squared times b. So first we apply the product rule. So we said log base 2 of a squared plus log base 2 of b, right? So that's the product rule of logarithms. And then we can apply the power rule next. So bring down the 2. So that's 2 times log base 2 of a plus log base 2 of b, right? Right. Part B, we have log base 3 of the quotient of 9m to the 4 divided by the cube root of n. So I would apply the quotient rule of logarithm first. So we say log base 3 of 9m to the 4th, which is the numerator, minus log base 3 of cube root of n. So I'm gonna go ahead and just rewrite that as n to the 1/3. So save me a step here. So n to the 1/3 is the same thing as cube root of n. And then furthermore, each of this log term we can expand further, even further. So like this one, you have a product and a power within the argument there. So I would just apply the product rule next, and so I'm gonna say log base 3 of 9 plus log base 3 of m to the 4th. Over here we have 1/3 comes out to the front using the power rule of logarithm, and then inside. This here we can even simplify. We know what that is from the previous section. We learned how to evaluate logarithmic expression. So log base 3 of 9 is asking for what is the exponent that 3 raises to get 9? Well, the exponent that 3 raised to get 9 is 2. So this becomes 2. 2 plus 4 log 3m, right? The power rule, so right, 4 comes down, minus 1/3 log base 3 of n. Exercise 3 is asking us to go backwards, meaning given expanded form, can we compress it? Can we condense it to a single log expression using these properties that we just mentioned at the top here. Okay, so let's do A. All right, so we need to have the same base before we apply the rule, right? So both of these log terms have the same base. So if we have a sum, then that become a product of the arguments, which is the 4 and the 16 here. Okay, so we do log base 8 of 4 times 16. So that's log base 8 of 64. Okay, now we can simplify this too if we want to, but it doesn't ask us to simplify. It just asks us to just write a single logarithm. So really, this is 2 here. Just make a note, but we're not asking to simplify it fully. Over here we have a difference. So if we have a difference, we verify the base are the same. So we say if there's a difference between 2 log terms, that becomes log base 3 of the quotient of the 2 arguments. Okay. D is a little bit harder, so I'll let you work out that on your own and see if you get the correct answer. C, again, we verify the base the same. So, but one thing is we probably want to bring the 3 in here first, just so that way we can apply the quotient rule of logarithm, because the quotient rule said that, and there's no we need to make sure there's no coefficient beginning of each of these log terms here. Right. Since there's a coefficient there, we need to bring that inside as a power. Then we can apply the quotient rule, right? Okay. D, I would do this first here. So combine these two using the product rule of logarithm, and also bring the 2 in here as well using the power rule, and then combine that afterwards. Okay, so that's all the example I want to cover for this lesson. Pretty straightforward lesson.